Batch normalization is a technique commonly used in deep learning algorithms to improve the speed, accuracy, and stability of neural networks. This technique is based on the fact that neuronal activations tend to shift and scale independently of each other, which can cause issues with the training of a neural network. Batch normalization is used to counteract these changes, allowing the network to learn more effectively. Firstly, batch normalization can address the problem of internal covariate shift. This is where the distributions of the input data to any layer of a neural network changes during a training step, making it difficult for the network to reach convergence. To tackle this, batch normalization normalizes the inputs to each layer by computing the mean and variance of a mini batch of inputs, and then applying a transformation which shifts and scales the data. This reduces the variability of the inputs and helps to minimize the amount of training data that is needed for convergence. Secondly, batch normalization also helps to reduce the number of parameters in a model, meaning that end-to-end training can be completed more quickly. Batch normalization works by maintaining stable statistics, e.g. mean, variance, for the inputs of each layer over time. This allows more of the network to be trained using fewer parameters. This also has the benefit of providing better generalization, as the trained model is less likely to overfit if there are fewer parameters. Finally, batch normalization can also help to ensure better numerical stability of the training process. This is because it normalizes and regularizes the inputs to each layer, meaning that numerical issues such as outliers and extreme values have less of an effect. This can help reduce the risk of gradient explosions that can occur and lead to poor training results. In summary, batch normalization is an important technique for improving the speed, accuracy, and stability of deep learning algorithms. By normalizing and regularizing the inputs to each layer, batch normalization is able to reduce internal covariate shift, reduce the number of parameters in a model, and provide better numerical stability. All these benefits make batch normalization an important part of many deep learning algorithms today.